Imagine a signal so small it's subatomic, traveling through the cold, dark void of space for 7 billion years. It finally reached Earth on November 23, 2023. To the untrained eye, it was just a blip, but to the scientists at LIGO, it was the sound of a cosmic catastrophe. Somewhere, halfway across the universe, two titans of the dark, two massive black holes, had just collided with a force that defies imagination. This wasn't just any collision. This was a crash so powerful it sent ripples through the very fabric of space-time itself. We call these gravitational waves. But here's the kicker. According to everything we thought we knew about physics, this specific event should not have happened. Today, we're diving into the mystery of GW 231123, the impossible black hole merger. How do you see something that eats light? Black holes are the ultimate ghosts of the universe. They trap everything inside. But Albert Einstein, over a century ago, gave us a clue. He predicted that when something massive accelerates, it creates ripples, like a stone thrown into a pond. For 100 years, we couldn't prove it. Why? Because the technology didn't exist. Einstein himself thought we'd never be able to measure something so tiny. But then, in 2015, we did. LIGO, the Laser Interferometer Gravitational Wave Observatory, is a feat of human engineering. Picture two 4-kilometer-long pipes at right angles. Inside, lasers bounce off mirrors polished to a precision of a billionth of a meter. When a gravitational wave hits, those mirrors move, just a fraction of the size of a single proton. It's like measuring the distance to the nearest star to within the width of a human hair. LIGO has heard hundreds of mergers, but the signal from late 2023 was different. It lasted only a tenth of a second, but it was 20 times louder than the usual noise. At first, scientists thought it was a mistake, a glitch in the system. But then, the second detector, thousands of kilometers away, saw the exact same thing. By analyzing the chirp of this wave, scientists calculated the masses of the two black holes involved. One was 103 times the mass of our Sun, the other 137. times. Now, to a casual listener, that's just a number, but to an astronomer, that number is a nightmare. It's called the mass gap. So, why impossible? Well, black holes usually form when a giant star dies and collapses, but there's a problem. If a star is too big, it doesn't just collapse into a black hole. It explodes so violently that it tears itself apart completely, leaving nothing behind. If it's a little smaller, it sheds its layers and leaves a small black hole. But right in the middle, between 50 and 130 solar masses, there is a forbidden zone. According to our models, stars shouldn't be able to create black holes in that range. And yet, here we are, looking at two monsters sitting right in the middle of that gap. It's like finding a species of animal that your biology textbook says went extinct 1 million years ago or never existed at all. Wait, it gets crazier. Not only were these black holes forbidden sizes, but they were also spinning fast, really fast. They were rotating at nearly the speed of light, about 400,000 times faster than the Earth. For a while, the mystery remained unsolved, until a team at the Flatiron Institute ran a new set of simulations. Their secret ingredient? Magnetic fields. They found that the parent star's magnetic fields act like cosmic brakes and accelerators at the same time. If the magnetic fields are just right, they can blast away the outer layers of a star while keeping the core heavy enough to fall into that forbidden mass gap. This discovery isn't just about two black holes, it's about how the most massive stars in our universe live and die. The mass gap isn't an empty void anymore. It's a bridge to a new understanding of the cosmos. GW 231123 has taught us that the impossible is just something we haven't explained yet. As our technology improves, who knows what other ghosts we'll find hiding in the darkness. Thanks for joining me on this journey through the stars. If you enjoyed this cosmic mystery, don't forget to like and subscribe for more. Until next time, keep looking up.